So today we're studying Pythagorean triples, and Pythagorean triples are any three whole numbers that satisfy the equation a squared plus b squared equals c squared. So there are lots of these families. For example, the first one is the 3, 4, 5 family. If you take 3 squared plus 4 squared, that's 9 plus 16, which equals 25, which is equal to 5 squared. The next family is 5, 12, 13. If you take 5 squared plus 12 squared, that's going to be 25 plus 144. That equals 169, which is 13 squared. So all of these families here, if you were to plug them into the Pythagorean theorem, you would see that those are the integers that satisfy that equation. So these families show up a lot. There's the 3, 4, 5 family, which we saw on the very first page. There's the 5, 12, 13 family, the 7, 24, 25 family, the 8, 15, 17 family, the 9, 40, 41 family. And these are the ones that I'm going to expect you guys to memorize. There's also an 11, 60, 61 family that's going to show up a lot of the time. And so it's going to be helpful for you to know that one as well. Now, these families are helpful because if you can identify which family it's from, you can use the similar triangles and the scale factor to figure out what the missing sides are. So the techniques to help by using Pythagorean triples to find the missing sides of a right triangle, the first thing we're going to do is we're going to look for a GCF. If there happen to be any mixed numbers in the problem, you want to change those to improper fractions. Sometimes there will be decimals in the problem, in which case you want to multiply by a power of 10 to remove them to make it easier to see the family. And even if no family is found, you can still use similar triangles with the Pythagorean theorem and the principle of the reduced triangle to figure out what those missing sides are. So we're going to do examples of each. So if we look at our first triangle on the page, we have 16 and 34. So I know that the GCF between those two numbers is 2. So if I take 16 and divide by 2, that gives me 8. And if I take 34 and I divide that by 2, that gives me 17. So this then is a member of the 8, 15, 17 family. And the side that's missing is 15. Now, if I multiply this family by 2, which is opposite of what I did to try to figure out which family it was a member of, so I divided by 2 originally, so I'm going to multiply by 2 to go back to the triangle I started with. And if I take 15 times 2, that tells me that my missing side is 30. On this next triangle, I see that I can take out a 10 from each of these. So if I divide here by 10, I get 24. If I divide 250 by 10, I get 25. So if I look at the triples at the top of the page, I see that there is a 7, 24, 25 family. And what I did down here was I divided by 10. So I need to do the opposite to get back to the original triangle. The side that I do not have is the 7 side. So 7 times 10 is 70. In the third triangle, I have some mixed numbers. So I want to change them to an improper fraction. So as a reminder, 2 times 1 is 2, add 1, that gives me 3. So this is 3 over 2. Changing this one to an improper fraction, 2 times 2 is 4, 4 plus 1 is 5, so this is 5 halves. So now I see that this is going to be, I see the 3 here and I see the 5 here. So what's happening is we're taking the 3, 4, 5 family and we need to multiply that by a half. The piece that was missing in this triangle was the 4. So we're going to take 4 times a half, or you could do 4 divided by 2 because it's the same thing, and we get that the missing side is 2. Now on triangle 4, there's a 1.4 here, and my preference is to not work with decimals, so I'm going to start by multiplying by 10, and that'll give me a 14. So that means I now need to multiply this the hypotenuse by 10, and I've got a 50. And now I see that the GCF between these two is 2, so I'm now going to divide by 2, which will give me a 25, and I'll divide 14 by 2, which is going to give me a 7. So now I can see that again I have a member of the 7, 24, 25 family. So I'm going to write that down. And I have to do the opposite of what I had done up here. If I had multiplied by 10 here, I now need to divide by 10. And then here I had divided by 2, so I need to do the inverse operation, which means I need to multiply by 2. The side that we don't have is the 24. So 24 divided by 10 is 2.4. And then 2.4 times 2 is going to be 4.8. So my missing side then is 4.8. In triangle 5, I look and I see the GCF on this one is equal to 12. So here I'm going to divide by 12. That's going to give me 1. Here I'll divide by 12, and that's going to give me 3. Now there are not any triples that have 1 for a leg and 3 for the hypotenuse. And so that we can still use this process though with the smaller numbers, because if you try to do 12 squared plus x squared equals 36 squared without a calculator, that would be very difficult to do. But instead, I can use these numbers, the reduced numbers. So I'm going to put 1 squared plus b squared equals 3 squared. So now this arithmetic we can do easily without a calculator. 1 plus b squared equals 9. Subtract 1 from both sides, we get b squared equals 8. Take the square root of each side, and we get then that b is equal to, that's going to simplify to 2 root 2. And so then we just need to do the opposite of what we had done before, just like on all of the other problems 1 through 4. Since I had divided by 12 here, I take this answer, the 2 root 2, and I multiply by 12. And so then that gives me 24 root 2. And that's going to be the missing side of this triangle, and it was easy to do without a calculator. So now when I get to this last problem on this page, I look and I see that my GCF between 9 and 12 is 3. So I'm going to divide each one by 3. And this looks like it might be a member of the 3, 4, 5 family. However, there's a problem because this 4 right here is the hypotenuse. And whenever you have a triple family up here, the last number is always the hypotenuse. The biggest side is the hypotenuse. And that's not what I was given in this side. If this were going to be a member of the 3, 4, 5 family, the hypotenuse should have been 5, and this leg here should have been 4. So this is not a triple, but we can still use the principle of the reduced triangle and similar triangles and scale factors. And I'll say that 3 squared plus b squared equals 4 squared. So now we're going to go ahead and solve for b. We'd get 9 plus b squared equals 16. Subtract 9 from each side and we get 7. Take the square root of each side and we get that b is the square root of 7. And then we just go back here and we do the opposite operation of what we had done, the inverse, which is multiplying. So we're going to take the square root of 7, we're going to multiply it by 3, and then that's going to give us 3 square root 7.